Hi, we are continuing drawing timings for flip-flops and latches. In this mini lecture, we will be analyzing JK 1-bit memories with four variants as usual. The first one is the flip-flop, which is positive edge triggered, and we mark these active edges first before we begin, and the initial condition is always the same, 0. Initial value of Q is 0. We simply maintain this 0 until the activity point in time. We look at the value of K. K is stable, is always 1. So now we have 0, 1. 0, 1 in state 0. State is 0 and there is 0, 1 on JK inputs, so we must stay with the same state. Then we change J, we have J equal to 1, so if you are at 0 in 0 state and you've got 1, 1, J1 and K1, you change to 1. And then similar situation, JK11 in state 1, you return to state 0, continue, you've got 0, 1, 0, 1 in state means maintain the same state. That's the first case. The second case will be drawn in blue. Let's say we start here in green, sorry, because I have denoted falling edges in green. So we must stay in 0 until the first falling edge, active edge, and you can see JK11 means change to logic 1, 0, 1 it means that you must 0, 1 in state 1. In state 1, 0, 1. That's it. You must return to 0. 0, 1 in state 0. You must stay with the same until the end. This is the second. Yes, this is the same case as this one. 0 on J, 1 on K means 0 on output. And the case when there is a flip-flop which is positive level triggered. Positive level triggered. As usual, we must analyze this periods of time when it's active and follow the rule, follow this diagram to predict the next state. So we start with 0 as usual, we stop and now analyze. J is 0 and K1 means 0. Next state is 0. When you've got JK equals 1, 1, it toggles the state to 1 and do it again because it is still active. So oscillations will occur, as in the case of JK latch, T-type latch. And when you stop it here, you've got you can stop this oscillation arbitrarily, either in logic 1 or logic 0. Okay, because it is not defined, cannot be predicted. So let's decide to have logic 1 for a quite narrow period when it is not active, and then this again active, and again 1, 1 is presented on its output, on its inputs. So there will be oscillation until this point in time, and then you've got 0, 1. 0, 1 means 0 on output, so you must follow this. You cannot choose 1. It is strictly defined that at the end of the oscillation the state will be 0. Okay? No more options. Only 0 is possible. You maintain this 0 until the next period when there is a JK11 oscillation occur, and then again the last state will be 0. It cannot be 1, because 0 on J and 1 on K means reset. Resetting means 0 on the output. And at to the end of this, then it is not active, no change. It is again active, but it is still the same command, 0, 1, so reset, and then oscillation 1, 1, toggle, toggle, toggle many times, and then return to its zero logic. Okay, it is also. So no choices other than 0 in between the oscillation. The only arbitrary choice was here, 0 or 1. Only 0 here, only 0 possible here, and only 0 possible here. Why? Because in this period, at the end of this activity, you've got the J1. Here at the end, you've got 0 on J. The same is true for this, and the same is true for this. Only in this case, at the end of the activity, J was 1. In the other cases, J was 0, and this forced 0 output. Okay, the last case is the low negative level triggered, and I will draw it in red. We start as usual with 0. Oh, sorry. Okay, 0, 0. Okay, because we must start analysis just from the beginning of the time axis. Because if it's J1, the oscillation will be present at the beginning. Because J is 0, when we start analysis, 0 will be present and maintained here. Then inactive, yes, yellow are now inactive periods. And then it is active and equal to 1, so the oscillation will occur, and the next state is undefined, and the stable state is undefined at the end of the activity, because it is J still 1, okay, oscillation. Then we enter the next activity, but on this activity we at the beginning have a J0, K1, which means reset, and then J returns to 1, and the latch is active. So there will be oscillations, and you have free choice of setting the state after the activity period, because it is equal 1 at the end of this period. So in the end, at the beginning of the next period, you've got 0, so it means reset. As usual, no change, and activity starts again here, but you've got J equal to 0, so no change. 0 will be, it is a reset. Okay. So here you've got two options, 0 or 1. The same is true here. Thank you.